Hello, my dear student. So today, so in last class, I think we discussed about the temperature. So different types of thermometer. Okay, and we have done calculations also. I have that you have understood. So today, we are going to proceed with heat. Okay, so it is also same chapter, that is temperature and heat. So today we are going to discuss about the heat. So heat is a form of energy. Okay, so before going through this chapter, okay, there are three modes of transformation of heat: conduction, convection, and radiation. Okay, so before starting this chapter today, I'll upload some videos. Okay, I have uploaded some videos, so you have to go through that one for today's lesson. Okay, so then in next class we'll continue with that chapter from book. Clear? So I'll explain in next class only. So today you'll just go through the videos, and I have uploaded some assignments. Okay, please try to do that. So for answer you can search net also, or you can do from book also. Clear? Okay, so bye bye.
Welcome to What is Heat? Let's start with an illustration. Here we have hot and cold blocks of some material, and they each have a thermometer in them to prove the point. If we put them together, what's going to happen to the temperature of the cold block, and what's going to happen to the temperature of the hot block? Let's take a look. You can see that there has been a transfer of energy from the hot block to the cold block, resulting in the same temperature for each. Heat is a form of energy that flows from one object to another. What kind of energy? That's right, it's the flow of kinetic energy. And it is important to remember that the temperature is the average kinetic energy of a substance, in contrast with heat, which is the flow of kinetic energy. So what direction does heat flow? You're right, always from hot to cold. This is a basic fundamental law of the universe. But how does that happen? What is happening at the particle level? And another interesting question to ponder is, will there still be any heat flow now once the two blocks have reached the same temperature? We will address that question a bit later. So to understand heat, we need to understand how particles are involved in the flow of kinetic energy. Let's back up a bit. Starting with hot and cold again, let's see what's happening between the hot and cold blocks. We'll take a closer look using a magic bus. As we zoom in, you can begin to see the particles that make up the two blocks. The kinetic energy is shown as vibrational motion. The lower block in red has greater vibrational motion. It has a higher average kinetic energy and therefore a higher temperature. The upper block in blue has less vibrational motion. It has a lower temperature. What happens when a slow-moving particle hits a fast-moving particle? There's a transfer of kinetic energy. And how does that affect their temperature? Yes, the cooler particle becomes warm. The hot particle becomes cool. Let's look again as we put the blocks together so the surface particles are in contact. The collisions constantly transfer kinetic energy, which is depicted here with the particles becoming purple and reaching a more intermediate rate of vibration, or in other words, reaching the same temperature. Note they need to transfer kinetic energy both between and within each block for this to happen. Let's get back to a previous important question. Is there any heat transfer now once they have reached the same temperature? Think about it. The atoms are still constantly colliding and so are constantly transferring kinetic energy, but there is no net change in temperature. The two blocks have reached an equilibrium once they reach the same temperature. The amount of heat going from upper block to lower is equal to the amount of heat going from the lower block to the upper block. The rate of kinetic energy transfer between the blocks is now equal, which defines the equilibrium. An important thing to mention is how the surface is being portrayed here, which is as a very smooth, unblemished surface. In reality, at the particle level, we would see an irregular surface with peaks and valleys, where only small localized contact between the two substances would occur and transfer kinetic energy. And yes, these particles are all vibrating. They have kinetic energy, but I will let you use your imagination for that. What is interesting about the gaps is that there are air molecules trapped in them, which we see here. The air molecules will act as an intermediary, colliding with and absorbing kinetic energy from the high kinetic energy hot particles, and then colliding with and transferring that kinetic energy to the slower cold particles and increasing their temperature. Eventually, the two blocks come to the same average kinetic energy, shown here as violet particles. So this video so far has demonstrated one of the three categories of heat, which we call heat conduction, the transfer of heat through the collisions of particles. There is also radiant heat and convection heat, which we will briefly touch on in the next two slides. Radiant heat is energy transfer through electromagnetic radiation, which is light. When photons are absorbed, their energy is transferred to the absorbing body, increasing the kinetic energy of its atoms. And of course, we can't miss this opportunity to show a partial dextro eclipse. Now on to convection, which is heat transfer in fluids. Convection describes the behavior of large aggregates of particles in a fluid, such as air or bodies of water, which does include kinetic energy transfer and other factors as well, depending on temperature differences between aggregates of fluid particles and other conditions within the fluid, all of which is beyond the scope of our video. This has been a Mad Scientist production. See ya.
Let's talk about heat transfer. What we're really talking about here is how energy moves, specifically heat energy, and how it gets from point A to point B, whether it be here on the surface of the Earth, up in the atmosphere, or even out in space. Heat transfer occurs really in three ways, and these include conduction, convection, and radiation. Let's take a look at each of these, starting with conduction. This is heat transfer as a result of molecular contact. The best way to understand conduction is by thinking about an example. So here I have a metallic spoon, and I imagine holding a match underneath it. Now what we know is that that spoon is going to heat up, and not just the part of the spoon that's over the match, but rather the spoon as a whole. And the reason this happens is because of conduction. Energy from the flame is causing the molecules within the spoon to vibrate, and that's transferring energy from one to the next, to the next, to the next, until the entire spoon has warmed up. That heat has transferred throughout the entire material. Conduction is going to happen most effectively in solid materials. But let's not forget about convection and radiation. Let's look at convection. This is heat transfer through or as a result of density differences. Again, let's grab that match, and let's think about this for a minute. I think we all know it's probably not the best idea to hold your hand above an open flame like this, and that's because a lot of the heat energy generated by that flame is going to rise. That is purely because of the process of convection. You see, what's happening is the flame is causing the air to expand. And when it expands, it becomes less dense than the surrounding air and therefore floats upwards. And with it goes some of that heat energy. That's what convection is all about. And this is going to occur most effectively within liquids and gases. Finally, let's think about radiation. Radiation is heat transfer by wave motion. Let's pull that flame up one more time. I think we know that because of convection, heat is going to rise, but it's also going to travel outwards in the form of waves of energy, electromagnetic waves. And that's the third type of heat transfer. Radiation is really interesting in that it doesn't need a material for it to travel. So this can occur out in open, empty space. In fact, this is how energy travels from Earth's sun to the surface of the Earth. And so if we look back, we have our three types of heat transfer: conduction, convection, and radiation. And it's important to know the key word that goes with each one. For convection, it's going to be density differences. For conduction, it's going to be contact. And for radiation, it's going to be waves. We can sum all three types of heat transfer up in one diagram by looking at something as simple as a campfire. Imagine that you're camping and you hold a pot of water or stew above that flame. Well, right now in this one picture, we are seeing all three types of heat transfer take place. There's conduction happening as the flame is transferring energy directly to and throughout the pot as a result of molecular contact. Additionally, there's convection as heat from both the boiling pot and the flame itself is rising up as a result of density differences. And finally, there's radiation occurring all around the campfire as energy travels away from the flame in the form of electromagnetic waves. And that's a quick look at heat transfer.
Heat transfer, conduction, convection, and radiation. Before starting the lecture, click on the subscribe button and get access to our 100 of conceptual lectures for free. Now, what is heat transfer and temperature? Let's consider two objects. Let this object is hot and this object is cold. The temperature of this hot object is 100 degrees centigrade and the temperature of this cold object is 5 degrees centigrade. This hot object possesses more heat energy than this cold object. That is why the temperature of the hot object is high than the cold object. Now, a natural process of transferring of heat energy or thermal energy occurs between these two objects. Heat or thermal energy from this hot object transfer to this cold object until both the bodies get equal temperature. For example, when heat energy transferred from hot object to cold object, let the temperature of hot object drops to 40 degrees centigrade and the temperature of cold object rises to 40 degrees centigrade. This state is known as a thermal equilibrium. Remember this important point which a lot of teachers skip and do not teach you. If two objects are in thermal equilibrium, it doesn't mean that heat energy doesn't transfer between them. Rather than this, if two objects are in thermal equilibrium, still heat or thermal energy transfers between them. But the net flow of heat energy is zero. For instance, if 5 joule of heat energy or thermal energy flows from this object to this object, then 5 joule of heat energy flows from this object to this object. Thus, the net flow of heat or thermal energy is zero, and these both objects are in thermal equilibrium. Therefore, remember that heat transfer is the flow of thermal or heat energy between two objects, while temperature only measures the amount of heat energy possessed by an object. Now, let me teach you the concept of conduction or what is conduction of heat. Let's consider a very hot object and you suddenly touch it. Your hand feels the hotness or your hand may be burned. Why your hand feel hotness? The answer is that some of the thermal or heat energy of this object transferred to your hand. As a result, your hand get hotness. Now let's consider another case. If you keep away your hand from this hot object, does you feel the hotness of this hot object? The answer is no. Because in this case, your hand touched this hot object. There is contact between your hand and this object. While in this case, your hand is away from this hot object. There is no contact between your hand and this hot object. So from these two cases, we learn that heat only transfer from hot object to cold object if there is contact between them. Or in physics, we say that flow of heat or transfer of heat requires medium. Here your hand is cold and when you touch this hot object, your hand provides medium to heat energy present in this hot object, and it travels towards your hand. As a result, you feel the hotness. Let me give you another example. For instance, you are cooking some sort of food. You always place the frying pan or pot exactly above the fire or flames. Why you do not hang or place the pan or pot away from the fire? So you aren't doing so. You always place the object straight above the fire. It is because there will be contact between your cooking object and flames. Thus, this contact will provide medium to heat energy, due to which heat energy or thermal energy of the flames would transfer to your cooking object, and food will be cooked by this way. Now, let me give you a deep dive so that you could learn the scientific explanation behind this phenomena of heat transfer. We know that cooking objects are made up of metals. The atoms of metals are closely packed together in a uniform three-dimensional pattern. When you place this cooking object or pot made up of atoms on fire, the atoms of this object get heat energy and start vibrating vigorously. Now this atom will transfer heat energy to this atom, while this atom will transfer heat energy to this atom. Hence, by this process, energy will start flowing among the atoms and your food will be cooked. Thus, this flow of heat energy from fire towards the cooking pot without transferring atoms or matter is known as a conduction or conduction of heat. Remember that different objects conduct different amount of heat energy due to their nature of material they are made up. Let's consider these objects. This object is made up of iron, so its thermal conductivity would be large, while the handle of this object is made up of plastic or wood, while plastic and wood are insulators. Hence, thermal conductivity or current conduction would be minimum in them. Now, let me clear your concept about what is convection of heat. Let's consider if you place your hand slightly above the fire, you feel the hotness of fire. In the previous slides, we learned that heat energy was only flowing when there was contact between hot object and cold object. But here in this example, your hand doesn't touch the fire, means there is no contact or no medium. Well, the scientific answer is very simple. Do you know the word fluids? The word fluids means gases and liquids. We also know that gases and liquids are in random motion. Are the molecules of gases and liquids possesses kinetic energy. Now here is the important point. The kinetic energy of gas and liquid molecules depend upon heat energy or temperature. Keep this point in your memory. And let me now explain this case. We know that there is air above the fire or flames. Hence, the gas molecule absorbs heat energy from the fire. As a result, the kinetic energy of gas molecules increase. Hence, they rise up and hits your hand. Thus, your hand being cold absorbs the heat energy from these gas molecules and you feel hotness. Therefore, remember that in this case, gas molecules or fluids are transferring heat energy from the fire to your hand. Another example of convection is boiling of water. Let's consider that we place an object filled with water on fire. Now there is contact between fire and this conical flask. So by the process of conduction, heat energy from the fire would transfer to the water. Now water being fluids its molecule will absorb heat energy from the flask and will rise up. Here let me ask you a question. Why these molecules of water rise up after getting heat energy? The answer is that they become less denser. And let me repeat this important point. The water molecule rise up because they become less denser, while the sand surrounding molecules of the water are more denser. Thus, due to this, they rise up. Now, the more denser molecules at the top falls down to the bottom. After absorbing heat energy, these molecules will also rise up. Thus, the less denser molecules of water rise up and the more denser molecules fall down. This process would be continued until all the molecules of water get heat energy. A time will reach that the kinetic energy of these molecules will be maximum and the change of state will start. Water will start boiling. Here, heat energy transfer in water by the motion of molecules from the bottom to the top. This motion is called bulk motion of fluids. Hence, the transfer of heat energy due to bulk motion of fluids from one place to another place is called convection of heat. At last, let me teach you that what is radiation of heat. Let's consider that during winter days, you sit in an open area for the sunlight. Do you feel the hotness of the sunlight? The answer is absolute yes. We absorb the heat energy of the sunlight. Now here comes the interesting question. Does this heat energy of the sun reaches you by the process of conduction of heat? The answer is absolute no, because there is large distance between you and the sun. Secondly, does the heat energy of the sun reaches you by the process of convection of heat? The answer is again absolute no, because when the air absorbs heat energy, the molecules of air rise up. Secondly, there is vacuum or space between the sun and the earth. Hence, the heat energy of the sun doesn't reach you by the process of convection. Then how this heat energy of the sun reaches you? Well, it reaches you by the process of radiation. So the heat energy of the sun is transferred by the process of radiation. Remember that radiation of heat doesn't require medium like that of conduction or convection. Thus, we can say that the transfer of heat energy without any material medium in the form of radiations or electromagnetic waves is known as a radiation of heat. Also remember that every object radiates some sort of heat energy until its temperature is absolute zero. And there is a difference between absolute zero and 0 degree centigrade. For example, you and I and everything around us radiates some sort of heat energy. Secondly, the higher the temperature of an object, the higher would be the rate of radiation of heat energy. So hot object radiates more energy than cold objects. At last, let me give you one bonus point. Remember that black objects are good absorber of radiation, like this t-shirt, while white objects are bad absorber are good reflector of radiations, like this t-shirt. In winter, people wear black color dress, while in summer, they wear light color or white color dress. I hope that you have learned the concept of heat transfer, conduction, convection, and radiation. Thank you very much for watching this lecture.
This water boiling, the heat of the fire, and cooking on the skillet are all examples of heat transfer. In simple terms, heat is the transfer of energy from objects of different temperatures. As objects warm up or cool down, their kinetic energy changes. Kinetic energy is the energy of motion. Temperature is a measure of the average kinetic energy of the particles in an object. As temperature increases, the energy of motion increases. As the water warms up and the temperature increases, you can see an increase in the movement. Heat can be transferred in at least 3 ways: conduction, convection, and radiation. Conduction is a process in which the transfer of heat takes place between objects by direct contact. It is most often associated with solids. The key to conduction is direct contact. The heat of the pan is transferred to the mini pizzas. The energy of the frying pan is transferred to the eggs. Notice that they are in direct contact. Convection is heat transfer by the movement of a fluid such as air or water when the heated fluid is caused to move away from the source of heat, carrying the energy with it. It occurs due to density. Lava lamps are examples of convection. As the liquid is heated, it rises and falls as it heats and cools. As the paper burns, the air is heated up and begins to rise. The burning paper is swept up in the convection current, cools, and falls back down. These beans are another example of convection. As the beans warm up, they rise and then cool and fall back down, and repeat this over and over again. Radiation heat is transmitted without any physical contact between objects. Watch how the temperature of the lamp is transferred to the thermometer without touching it. These alligators and lizards use radiation from the sun to warm their bodies. If you'd like to know more about heat transfer and conduction, convection, and radiation, this playlist will help. And as always, thanks for watching. And Moo Moo Math uploads a new math and science video every day. Please subscribe and share.